In finance, the central question is not only how much money you have, but when you have it. That is the idea behind time value of money. A euro today and a euro in the future are not treated as equal, because the present euro can be used, invested, or protected against uncertainty right away. In this lecture, we will build the core vocabulary: present value, future value, compounding, discounting, multiple cash flows, and net present value. Present value is the value of a sum of money today. It answers the question, what is a future cash flow worth right now? Future value is the value of a sum of money at a specific time in the future. It answers the opposite question, what will today's money grow into later? The direction matters. Present value calculations move money backward in time, while future value calculations move money forward in time. That forward or backward movement is the whole logic of the topic. The timeline is the visual tool that makes time value problems manageable. The source emphasizes that the periods on a timeline must always be equal, so each step represents the same amount of time. Cash inflows are written as positive numbers, and cash outflows are written as negative numbers. That sign convention matters because it lets you see benefits and costs at a glance. Once the timeline is set up correctly, the rest of the problem becomes a matter of moving each cash flow to the chosen date. Compounding and discounting are mirror images. Compounding moves money forward in time, so it increases the value of a sum and uses multiplication. Discounting moves money backward in time, so it decreases the value of a sum and uses division. Compounding gives you future value. Discounting gives you present value. If students remember only one thing here, it should be this. Compounding asks what today becomes later, while discounting asks what later is worth today. The direction of time determines the operation. The source gives the two core formulas directly. For compounding a cash flow over n years, future value equals C0 times 1 plus r to the power of n. For discounting, present value equals C sub n divided by 1 plus r to the power of n. Here, C means cash flow, n means time, and r means the return earned in decimal form. The formulas are not separate ideas. They are the same time adjustment written in opposite directions. One pushes value forward, the other pulls it back. When there are several cash flows, you cannot add them directly unless they are all measured on the same date. The source states this rule clearly. To compare or combine cash flows, they must be moved forward or backward to the same point in time. That is why timelines matter so much. First, you choose a date, then you move every cash flow to that date using compounding or discounting, and only then do you add them. This is the bridge from one cash flow problems to real investment analysis. Net present value, or NPV, is the difference between the present value of all benefits and the present value of all costs of an investment. Benefits are the positive cash inflows. Costs are the negative cash outflows. The source's formula is simple. NPV equals present value of benefits minus present value of costs. The key interpretation is practical. If NPV is positive, inflows exceed outflows in present value terms, which is an indication that a firm should invest in the project. NPV is the decision rule built from time value of money. The source's first worked illustration shows repeated cash inflows of 12,000 euros across several periods, with the present value found by discounting each payment back to today. The important idea is not a special shortcut, it is the method. Every future inflow gets its own discount factor, because each payment arrives at a different time. Then the discounted amounts are summed into one present value at time 0. The exact return rate is not specified in the extract, so the point here is the structure of the calculation, not a numeric answer. The source's second worked illustration uses repeated 2,000 euro inflows and moves them forward to a common future date. The formula written in the extract shows each payment compounded by the appropriate number of periods, from the earliest payment all the way to the latest one. That is the future value version of the same logic we used for present value. Adjust each cash flow to one shared date, then sum the results. Again, the source does not specify the return rate, so the lesson is the pattern of compounding, not a numerical endpoint. A reliable workflow makes time value problems much less intimidating. First, identify the cash flows and place them on a timeline with equal periods. Second, mark inflows as positive and outflows as negative. Third, choose the date you want to end up at. Today for present value, a future date for future value, or a decision date for NPV. Fourth, move every cash flow to that date with compounding or discounting. Fifth, add the adjusted values and interpret the result. That sequence is the practical takeaway from the source. The source gives the key decision rule. A positive NPV is an indication that a firm should invest. That means the present value of benefits is larger than the present value of costs. If the result were negative, the reverse would be true. The project would destroy value in present value terms. This is why finance uses NPV instead of comparing raw cash totals. It forces all future amounts onto the same date before making the call. Once you do that, the decision becomes much clearer. Here is the whole idea in one sentence. Time value of money means you cannot compare cash flows until you move them to the same date, using compounding to go forward, discounting to go backward, and NPV to decide whether a project creates value. If you remember the timeline, the formulas, and the sign convention, you have the core toolkit from this source. Everything else is just practice with that toolkit.